Our universe is a place of infinite variety. 2 trillion galaxies. Billions and billions of stars. And countless planets. Worlds beyond imagination. The universe is so vast, so incomprehensible, so terrifying, that I think it's quite natural for us to choose to live out our lives completely oblivious to it. Perhaps that's why there's a sense of relief that rises with the dawn. The brightening sky hides the stars and the questions that they pose. After all, they are the biggest questions. How did the universe come to be? Why are we here? And how will it all end? We have to face those questions if we're ever to acquire a truly deep understanding of ourselves. You see, astronomy challenges us. From one perspective, we're just grains of sand adrift in an infinite and indifferent ocean. But from another perspective, we are nature's most magnificent creation, collections of atoms that can think and wonder about the universe and choose to explore it. In our quest for answers, we're venturing ever further from home, far beyond the planets and out to the stars. Our spacecraft are sending back a stream of extraordinary revelations, visions of alien worlds, with the ingredients to create life. We've seen galaxies collide, black holes devouring star systems, and we may have glimpsed the origin of the cosmos itself. With every new observation, every new piece of knowledge, there is the opportunity to acquire a deeper understanding. And as we answer question after question, we get ever closer to being able to tell what is surely the greatest story ever told. We have to go back to a time before the stars. In the beginning, the universe was dark. But it was not empty. Something was lurking in the void, stretching out tendrils. The cosmic web grew to become a vast structure. Crisscrossing the entire universe. It was formed by interlocking filaments of dark matter. And it was at the places where these filaments met, the intersections, that the first stars, our sun's earliest ancestors, were born. The cosmic web is the scaffolding of the universe, the vast and intricate structure that spans the void. The web is made primarily out of dark matter, a mysterious substance that dominates the universe. Although we don't know what it is. It's one of the great mysteries in modern physics. It's probably some kind of particle that interacts very weakly with itself and with light. And if it doesn't interact with light, you can't see it, which is why it's called dark matter. But it does influence the universe through its gravity.
It was in the dark heart of the cosmic web that gravity began to sculpt the early universe, drawing together the two simplest elements, hydrogen and helium, the raw material for the very first stars.
Hydrogen gas clings to the filaments of the web, attracted there by the gravitational pull of the dark matter. And where those filaments cross, the gas can become dense enough to collapse under its own gravity to form great clusters of galaxies, each filled with billions of stars.
Nuclear fusion. Fusion occurs when atoms are smashed together at a high rate of speed and literally fused. To get this to happen, conditions have to be just right.
For any interaction to happen, these two protons each has a positive electric charge, and so they would repel each other. So you've got to get them close enough together. And to do that, it's got to be hot, which means the particles moving very fast, and dense enough that they hit each other and they can get close enough together that they actually fuse.
These objects are hydrogen atoms flung together by immense pressure to form helium atoms. In this fusion process, the resulting atom is slightly less massive than the ones that created it. The missing mass is given off as energy. Each second inside the sun, 600 million tons of hydrogen are fused into 595 million tons of helium. That 5 million tons of mass lost in the process is converted into energy equal to 1 billion 1 megaton hydrogen bombs. That's every second.
When you look out into the cosmos, the process that gives you the highest return of energy for free is what goes on in the centers of stars like the sun.
The universe was approaching a turning point. Hydrogen and helium poured into the regions where the filaments crossed, gathering into ever denser clouds. Gravity asserted its grip, and the clouds of gas began to collapse. Becoming denser and denser. And in the densest regions, the gas became so hot that nuclear fusion reactions began. And there was light.
of solar violence is magnetism. Since Earth rotates as a solid, our magnetic field is simple. We have two poles, north and south. This is what makes a compass so useful for finding your way around the planet. But imagine if instead of two poles, you had 1 to 10 million. This is what happens on the sun. The sun's magnetic field is a tangled web because even though it's held together by gravity, the plasma doesn't rotate evenly. Plasma at the equator rotates once every 25 Earth days, while plasma at the poles takes roughly 35 days to circle once.
The sun has what we call differential rotation. You have all of this plasma that is really turning and churning, and that causes magnetic field lines to become twisted and intertwined and mixed up.
Although magnetic field lines are invisible, we know they exist on the sun by looking at features called coronal loops and prominences, rising up into the solar atmosphere. Just as metal shavings line up in the presence of a simple magnet, these loops of plasma perfectly outline the magnetic structures that support them from below.
What happens is the sun reverses the direction of its magnetic field every 11 years. So in 22 years, it reverses and comes back to where it was.
As we near the reversal every 11 years, the number of sunspots increases, and there's a spike in solar activity.
We call that period solar maximum. And those periods are interspersed about 5 years apart from periods we call solar minimum.
Where the sun's magnetic field is at its most twisted and complex, heat bubbling up from below is capped, and the material is cooled by as much as 1,000 degrees. What results are relatively dark blemishes on the solar surface called sunspots. Sunspots are only dark in relation to the bright material around them. If you could somehow suspend one alone up in space, it would shine 10 times brighter than the full moon. These apparently tiny blemishes are actually plasma craters the size of the entire Earth. Galileo was one of the first modern scientists to observe sunspots. Using a telescope, he projected an image of the sun onto paper and traced it. He realized that the blemishes were moving across the face of the star, which was the first indication that the sun rotated. Not only does the sun rotate, but sunspots themselves can actually spin like hurricanes on the solar surface. And when they do, their magnetic field lines become extremely twisted. Twisted magnetic field lines mean more energy, and more energy means the potential for huge eruptions. When a sunspot unleashes its magnetic energy, what results are the most colossal explosions in the solar system.
NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star.
This is a journey into Never Never Land, you might say.
NASA's Parker Solar Probe is the first spacecraft to touch a star. It It's designed to fly through the sun's atmosphere, braving temperatures no spacecraft has ever endured. The Parker Solar Probe is allowing us to know our star as we've never known it before. And it's also helping us to tell the story of all the stars. The first stars were monsters. Hundreds of times as massive as our sun. They burnt with such ferocity that they shone blue. With surface temperatures in excess of 100,000 degrees. They were the largest stars ever to have lived. Violent and volatile giants.
A star is essentially a balancing act. The force of gravity is constantly trying to collapse it, and that pushes its ingredients, primarily hydrogen, single protons, closer and closer together. Now, when those protons get close enough together, another of the fundamental forces of nature, the strong nuclear force, takes over, and it can stick the protons together. That releases energy, which creates a pressure, which holds the star up. Now, the more massive the star, the stronger the inward pull of gravity, and the more energy has to be released to maintain the balance. And so the faster the ingredients are used up.
These giant stars were in a struggle for survival, fighting the relentless pull of gravity. Consuming more and more hydrogen fuel to maintain their precarious equilibrium.
For most of its life, a star burns hydrogen, the simplest chemical element, with one proton in its nucleus, into helium with two protons. Now, when it runs out of hydrogen in the core starts to collapse and heat up, and the star responds by building ever more complex elements. So it makes carbon with 6 protons and oxygen with 8 protons, releasing more and more energy as it goes. But when the star has assembled iron in its core, with 26 protons in its nucleus, no more energy can be released. The star loses its battle against gravity. It collapses. And in a final moment of creation, salvaged, if you like, from its destruction, it distributes those newly minted heavy chemical elements out into the universe.
Imagine we could journey back in time and watch the first star live out its brief, luminous life. After only 1 million years, the star used up all of its fuel. The core collapsed. The star imploded. And then rebounded in a colossal explosion, a supernova.
Why do scientists believe the sun was born from the ashes of a supernova? The evidence lies beneath our feet. Complex, heavy elements like the uranium we mine from the Earth to fuel our nuclear power plants could not have been forged in the sun. There is simply not enough heat in a star that size to create elements any heavier than iron. Heavy elements like uranium can only be created in a catastrophic cosmic explosion. Earth and the other planets in the solar system formed out of the same knot of gas that produced the sun. In this process, the sun hoarded 99% of the mass. This means it's the biggest object in our celestial neighborhood with the strongest gravitational pull.
In death, the first stars began to transform the cosmos, enriching the ocean of hydrogen and helium which filled the universe with heavy elements to build new generations of more complex stars. Over time, these elements gathered together, creating rich clouds of gas and dust. Nurseries where new generations of stars were born. And not just stars, but families of stars. The first galaxies. And around this time, some of the earliest star systems formed in our own galaxy, the Milky Way. A new age of complexity was dawning in the universe. Now there were stars of different sizes. And different colours. And crucially, new bodies had appeared. Planets. Places where the rich chemical elements, built by previous generations of stars, could finally find a home.
Countless billions of stars have come and gone since those first giants
illuminated the darkness, each enriching the universe with the material out of which the next generation formed. Blue stars and white stars, single stars, double stars, even triple star systems orbiting around each other. The conditions were now right for those stars to drive the universe into a new and profound age of complexity. There are over 200 billion stars in our galaxy. And there are 2 trillion galaxies in the observable universe. We're living in the age of stars. An era of light and life in the cosmos. From our fleeting human perspective, stars seem eternal. Where there is light, there is darkness. Stars are creators. But they can be jealous guardians of their creations. Many smaller stars don't die in spectacular explosions. Instead, they slowly fade away. They hang on to the precious elements they made, becoming fossil stars. And as more fossils litter the universe, more life-giving elements remain locked away, starving the cosmos of the material needed to make new generations of stars. The age of stars may seem infinite, but it had a beginning, and it will also have an end.
Imagine a timeline of the universe, and imagine that this is the origin of the universe, the Big Bang, 13.8 billion years ago. After 100 million years or so, the first stars formed. On this scale, 1 centimetre is about 20 million years. After 4 billion years, the peak rate of star formation occurred. The maximum number of new stars were born. After 9 billion years, our sun was born. And today, we stand 13.8 billion years later, about halfway through the lifetime of our sun. Now, in about 5 billion years' time, our sun will die, but new stars will be born, and many of the older stars in the universe, the smaller stars, will continue to shine. In fact, we think that the last star will cease to shine, the universe will go dark, in around 10 trillion years. On this scale, that's about 5,000 meters away from the Big Bang. But that's not the end of the universe. As far as we know, the universe will continue expanding forever. And so the age of starlight is the briefest moment of time in the infinite history of the universe. The age of darkness will go on and on and on. Stars won't just disappear, of course. They'll be here for eons to come. But over time, the universe will grow darker, colder, and emptier. There are stars around today that existed close to the beginning of the age of stars. And some of them will also witness the end. They're the longest lived stars in the universe. Red dwarfs. TRAPPIST-1 is one of these ancients. It's already more than 7 billion years old, almost twice as old as our Sun. But only around 1/10 of the size. And less than 1% as bright. It's a cool star, slow burning. And that is the secret of its longevity. Because they burn slowly, red dwarfs live for a very long time. Far longer than any other star. Like the Sun, TRAPPIST-1 has its own planets. 7 rocky worlds, each roughly the size of Earth. Some may have atmospheres and even oceans. But there the similarity ends. Because these are strange worlds. Every one of these planets is locked in its orbit. One side facing TRAPPIST-1, the other side frozen, permanently exposed to the cold void of space. If you could stand on the surface of one of these ancient worlds, as the eons passed, you could watch the future of the cosmos slowly unfold. One day, 5 billion years from now, you'd see our sun flicker and fade away forever.
The universe could live forever, with the timeline stretching far off into the distance. And that means that the age of starlight that I've mapped out here is like the blink of an eye to the universe. It's the age of darkness that goes on and on and on.
Stars won't suddenly disappear, of course. They'll be here for hundreds of billions, perhaps even trillions of years to come. But slowly, over time, the universe will become darker, emptier. As it expands, the distances between these little islands of light become greater and greater. As its fuel runs out, fusion comes to an end. The last star slowly cools and fades away. With its passing, the universe becomes cold and dark. Without light, and most likely, without life.
The death of our sun will probably go unremarked. I doubt that we'll be around to see it. Maybe some alien astronomer on a world far away across the Milky Way will see it through the end of their telescope. But I don't think they'll give it a second thought. I mean, we've seen hundreds of stars die, and we don't give them a second thought. But I think the death of our sun will matter here, locally, in this little corner of the galaxy, because it will mark the end of a glorious time in the history of our galaxy, where meaning, where science and literature and art and poetry and music existed here. And that does matter. I mean, why does meaning have to be eternal? It's the fragility of our lives that makes them valuable. I think the wonderful thing is that our star has taken the laws of nature here on this planet and crafted such a magnificent expression of them. You and me and all this. Stars like TRAPPIST-1 will linger on long after the death of our sun. We will never know the name of the last star. But we know that the last star to shine will be a red dwarf. The last star will slowly cool
and fade away. With its passing, the universe will become, once again, a void. Without light or life or meaning. Our sun is from a long line of stars dating back to the dawn of time. From fierce blue giants which first lit up the universe, to later generations whose deaths enrich the cosmos with precious elements. The building blocks of our solar system. And allowed our sun to create the thing which brings meaning to the cosmos. Life. You and me. The stars illuminate the universe, but that is the least interesting thing that they do. The thing that makes the universe interesting, that brings meaning to the universe, is that life, you and me. And life is just chemistry. And chemistry requires complex chemical elements. The only thing that existed in the universe before the stars was hydrogen and helium. Life requires carbon and oxygen and iron. All those things were made in a process called nuclear fusion, in the cores of stars, or even for the heavier elements like gold, in the collisions of stars. So, without the stars, the universe would be uninteresting. It would be meaningless. It would be just an infinite box of gas. No one knows exactly how life on Earth emerged. But what we do know is that at some point, primitive cells living in the ocean began using the sun's energy to power life-giving chemical reactions. These cells formed a bridge between Earth and sun. Delicate engines which harness the fires of our star, using sunlight to turn carbon dioxide and water into food. This process, known as photosynthesis, unleashed the sun's creative power. And drove the evolution of complexity. From primitive bacteria to plants and trees, and ultimately to you and me. Now, photosynthesis is a process that's very easy to describe in words. The plants take energy from the sun and use it to react carbon dioxide and water together to make sugars and a waste product, oxygen. Really easy to say, very difficult to do I mean, there's a part of that photosynthetic machinery, everything you see here, every plant on the planet called photosystem 2, it's comprised of 46,630 atoms, all working together in an intricate machine. Very efficient. It took billions of years of evolution. Then we eat the plants, or we eat something that's eaten the plants, and we do the reverse reaction. We take those sugars and we breathe in that waste product, oxygen, react them together, release a bit of energy, a bit of the stored sunlight, if you like, and we use that energy to maintain our structure, to grow, to live. Trillions of stars have existed since the universe began. But ours has nurtured that most miraculous thing, life. And that makes the sun a truly remarkable star. That is the only star we know of anywhere where there are collections of atoms in orbits around it, you and me, that have named it. We don't need to invent imaginary gods to explain the universe. We can replace them with the real thing. Everyone we love. Everything we value. Our supreme accomplishments as a civilization were created and crafted by stars.
The most dangerous man you will ever meet in your life is the one who healed alone. And I don't mean dangerous like violent. I don't mean rage or chaos or anything like that. I'm talking about the man who was shattered by life at some point and made the decision to rebuild himself brick by brick with no help from anyone. The man who walked through experiences that stripped him all the way down to nothing, who faced truths about himself and about the world that most people spend their entire lives actively avoiding. He saw the world without any of the fillers, without the illusions, without the comforting little lies we tell each other to make reality easier to swallow. He's the man who hit rock bottom so hard it left him unrecognizable even to himself. And somehow, against all odds, he found the strength to get back up anyway. When everything in his life fell apart and every single person quietly disappeared, he learned something most people never have to learn. He learned that the only person he could never abandon was himself. And that knowledge changes a man permanently. A man who faced his darkest night alone walks different. He talks different. He gains a clarity and a self-trust you simply cannot fake. He doesn't fear being alone anymore because he's already been there and survived it. He outgrew the need for anyone's approval somewhere along the way, and he didn't even notice when it happened. A rebuilt man doesn't get his power from who's standing next to him. He gets it from remembering who he became when absolutely nobody else was. He isn't fragile, he isn't lost, he isn't searching, he's intentional, he's grounded, he's self-reliant in a way most people will never understand.